So the purpose of this webinar was that I was always curious to know if there's a difference between the different bilocators for with Selenium. And when I first started with Selenium, there was always this issue with a CSS or XPath. One of them is going to be faster, one of them is going to be slower. And nowadays it's pretty much non-existent, but I was still curious, like what happens if we do, instead of the by.id and then pass in the ID that we wanted, what happens if we did it by .css selector and use the hashtag with the CSS selector, with the ID as well, just using it as a CSS selector instead of by ID. Essentially, it was all just curiosity. So the way I recorded all this stuff was, let me show you my Python project here. So let's just look at the Firefox one. So this is just to dump large amounts of data into a data store. But what we have here is starting up a Firefox instance, and using an instance, we're going to do all these different locator types. These are different locators that were used. I used the website, the internet.herokuapp.com/large, which has this nice, really long and deep DOM to use. Here's just a few different CSS locators. Probably once this webinar is done with, I'll probably have it keep recording some more data and just let everybody explore the data as you want. The run command is doing all the processing, so let's show the declaration of that. Maximize this window. So here, it's going to go to that URL. It's going to make a little dictionary called BL for by and locator, and then we're going to do the call on the locator. So up here is the call. Driver find element by and locator. Nothing complicated there. What's really cool is this little wrapper attribute, little metadata, which is defined here. And what it's going to do is whenever I call this call command, it's going to do this action, but it's going to record the start and end time for it, and then return that as the result. So that's what that call is going to do, and that's saving that number to the stats. Then I'm going to use this little method here to get the parse the navigator.userAgent, so I know exactly all the information there is with the user agent. And then here's the fun command to post to Elasticsearch, and setting up an index, doc type, user agent, blah blah blah, yada yada. Here I'm also getting if the driver was either a remote driver or a local driver. As you can see, this little Python file over here, I actually have some tests running against Sauce Labs. So I wanted to make sure I can filter out those records as well once we start looking through the data. Let's see here. I then index the files into Elasticsearch. This little toDict method which is two dictionaries, what it stands for Python, just gets all the records from this user agent parser that I find relevant. Is mobile, is PC, is it a tablet, what version of Firefox, and all that other fun stuff. Let's go over here. The data store I used was the Elk Stack, Elasticsearch, and Kibana. Whatever it was, Logstash. So I guess it's just called the X Stack. And let's go ahead and dig through the data. If you have any chat questions, you can put a message into the chat window, and we can look at that particular data there. Go over here. So here's the dashboard with records. So notice things first off the top is that Edge is a very slow test, but that is because it's a remote server that's running it. So that's all the Sauce Labs tests. So if I were to do, let me see, what did I have that record type as? Driver type, okay. So driver underscore type. So this is returning only the local tests that were executed. And by local means I set up actual EC2 instances on Amazon to run tests on Windows machines, and using those virtual machines, it's running the IE or Firefox or Chrome locally on those servers. So it's the local result. Local result. IE is considerably slower, but it's what, 9/10 of a second being executed, whereas Chrome, Firefox, Phantom, Safari is all 0.01 seconds, which is kind of cool there, that it's that much faster than the Internet Explorer. I'm surprised Safari is the fastest out of all of these records, though. So let's look at the let me see, I have this as locator. Large table. Okay. Let's see. Let me just eliminate that one. Come on now. Filter out those records. All right, so what I'm trying to do here is trying to look up what the, we'll just look at the CSS one first. Why? Okay, we'll just do it this way then. Let's see. All right, so this is just by the XPath, which is surprisingly fastest in Safari, but Safari was faster all around. Come on now, let me show one other one. table. Why is it not letting me do stuff? Oh. I should move this. So look at the records. So on average, the by.id and the CSS locators are pretty much the same. The large table is the ID, so that was during a search by.id. Not surprising that the link text and partial link text is slower, the slowest of them all typically. Which are these nice purple ones. Let's see. Now let's look at what the remote ones look like. So here the times are way longer, a third of a second. And that's because the command is going from my computer, getting sent over to Sauce Labs, being executed, and then comes back. So it has to account for all that network traffic as well. If you want to search the data yourself, you can actually just go to this URL here, cabana.lazycoder.io, and you can actually just filter through all the data there. There's a dashboard as well on the side there that you can see the performance. You can go to, probably just look with this one, so this is just as perf. And you can see the total number of records that are in there as well. So there's a substantial size there. All of this code is on GitHub as well. I haven't run the headless test yet because if I were to run that headless test at this moment in time, it's probably going to make the records go out of whack because it might run faster. Let me go ahead and update GitHub. Did anyone have any questions on any of this? This was more just me messing around and me messing around and just looking up data records, and surprisingly, Internet Explorer XPath is slower. Kind of shocked by that because back when Selenium 2 was around at the very beginning of it, the XPath with IE was faster than CSS selectors, but that is apparently no longer the case, which is interesting. Cool. Oh, hey, we got Joe Cole Antonio here in the house. Let me look at my main screen here. Audience. Cool. What's up, Joe? Was there any, if anybody has any questions, I can actually bring you into the live stream if you open up the chat and go to Q&A and just ask a question, you can just start it off with live at the beginning, and I can pull you into the webinar live. Oh, Joe just joined. Oh, man. No worries. You can pretty much just look at all of the records up here at cabana.lazycoder.io. There's all the records getting dumped there. The GitHub project, which has all the code on it now. Is running really slow for me because that's awesome. Locators perf. I'll update it with a README after this webinar is over. Oh, we got a question. Oh, unrelated topic from Joe Colantonio. Hard time making he has a hard time making visualizations in Kibana. Such as what in particular, I guess? Or actually, you know, we can do it live. Do you want to do it live, Joe? Start off with, yeah, why not? Let's do it. Cool, you should have access now. Historical data like flakiness over time. All right. So, one definite thing to do is when you first index your, when you first load up Kibana, you have to set up an index. When you create an index pattern, obviously you're gonna have to match whatever your index you're going in, but you make sure you have to have a time filter field as well, so which will have a time date stamp. Let's see here. I already did that actually with my current index with the browser. If you look, there's a date timestamp. So we can do, let's do a visualization. Actually, we can essentially do flakiness over time with what I already have. It won't really be flakiness, but it would be the metric. So here we're going to do an aggregation of the, not some, you want mean, average of executable time. X-axis is going to be date histogram, date time field auto, and sub bucket, split series. So what we're doing here on the x-axis is going to be the date histogram. So it's going to be the date time. We're splitting up the series, so we're going to have multiple lines based on, in this case, we're going to do terms and do it based off of the locator type keyword. We're going to just look at the top 5. And we're going to hit run. Let me filter this down a little bit. 12 hours. So there you can see sort of what the normal records have been going for whatever reason at 11 o'clock. X paths were taking a much longer time. Looks like here, right when I started up the webinar, it sort of spiked up a little bit. Looks like it's leveling off right now. We can also There's another sub bucket with Kibana. You can actually split the chart. So here we're going to do it off of the, let's do terms again, and we'll do it off of OS. So this is the families. What type is the agent? What type is the operating system? And run, and we should get split it out. So here we have, looks like Linux is down here, Macs and Windows should be at the bottom here. Better one to use would probably be the driver type if it was local or remote, because that should just break it down to 2. So we have two lines there, and it keeps the same scale for the two data sets for this. So here, because we have this nice spike up here, we have 0.6. It has to go up to display records for. Apparently the remote test has stopped running, so we run that sucker again. Does that answer your question, Joe? He says cool, so I guess that's cool. Was there anything else you wanted me to look into? Does anybody have any, what I'm looking for here? Any sort of slices of information you want to look at? Because you can always slice information up here using the search filter up here. Well, I guess if there's no other questions, we'll wrap this one up for the day. That one. Cool. So if you guys want to, you can always look at the data at kibana.lazycoder.io. I'll probably add more record types to it with remotes, with headless browsers as well, since I know the AWS running tests on AWS Lambdas go a whole lot faster. I'm wondering if that shows up in the calls as well. So I'll try adding those data records this weekend. Have a great, in 2 weeks, I'll be doing a webinar on the security testing with Zap, OWASP, Zap, and Selenium, which will have a whole bunch of free code that you can use and do security tests on your website for very little setup. If you want to, you can sign up here. And hope to see you then. Have a great day, everybody.